Oh, hello, I'm Tim Neal from precisionagriculture.com.au. This is the first part of 4 sections about guidance systems and using AutoStee systems on your farm. The first section we're going to focus on how does it actually work. A lot of people buy this stuff and don't really realise or understand how an actual RTK high accuracy guidance system works. So the first section we're going to show you some of the background about how these systems work. Okay, guidance systems. You guys are interested in guidance. I've introduced a new term for you here. GNSS is the new term. You'll hear a lot more about GNSS in time. You'll hear less about GPS. GNSS stands for Global Navigational Satellite Systems. So what GPS is actually only relates to American satellites, okay? There's only the American constellation. There's going to be a heap more constellations launched over time from all other sort of countries. So you're going to hear more about GNSS than GPS in the future. We started handheld GPS, right, which is accurate to around 5 metres over time. Differential, which you're talking about, is DGPS, which can be anything from 10 centimetres to 1 metre plus. And they often sell them as sub-metre systems or whatever, but that sub-metre means up and back, generally pass-to-pass accuracies. They're not quoting 24-hour periods. Some companies like OmniStar offer very good solutions, and they will be pretty well repeatable at 10 centimetres. John Deere offer Starfire 2, Starfire 1 and Starfire 2 as DGPS corrections. The higher end is called RTK, real-time kinematic, and that's what we're going to talk about here, where you have your own base station. And you can see on this diagram here that the base station is picking up the same satellites as what the tractor is. It needs a minimum of 5, and it then, because there's so many atmospheric errors and clock errors and GPS errors that are happening, and all through this section here, between where the satellite is and where you are, it can introduce a whole heap of errors, and mainly through the ionosphere is where a lot of the scattering and errors come in. So the base station is not moving, but it's doing corrections at a great rate of knots, but it still thinks it's jumping around like this. So it just knows what those errors are by calculating those things in real time, and then it punches that correction, for want of a better term, back to the rover every second. So generally, less than every second, that rover will be getting an update from the base station about what its correction should be and what errors are coming through. If it creeps up to 3, 4, 5, 10 seconds, we start getting a real degradation in the accuracy. So it needs regular updates from the base station all the time. Is there any questions on that? So the important things are, this is the radio link, that's the GPS. That's or the GNSS receiver. The receiver is here, that radio is transmitting out to the rover.